All right, so welcome everybody. My name's Eric, and you're here for a workshop on using GitHub Actions for automating scientific workflows. So thank you all for coming. And see, before we get started, I will share some links. So these slides are published on the web. And I'll put that in the Zoom chat there if you're interested in following along. Hey, Jeff. We'll also be today working with this template repository, and I'll put that link in there. You can, it's this page here. You can go ahead and open that up. We're not going to do anything with it just yet. So and I also, before we get started, just want to acknowledge that this is very heavily inspired by a longer format workshop that I attended at the US Research Software Engineer conference, or it was actually before the conference virtually, presented by Valentina Staneva, Quinn Brencher, and Scott Henderson. And all of their materials are linked here, and I'll also send them in a follow-up email to everybody that registered. And they're, again, like for a longer format workshop, a little bit more advanced, I guess I'll say, different examples, more Python focused than what we're going to see today. So these are all great like follow-up resources if you want to go through and do some self-study afterwards. So we're going to give you like a little sampler today, and yeah. So today, by the end of this workshop, hopefully you all will kind of understand the role of GitHub Actions workflows in research software development. And I'm just going to pause there and just say that if you write code for analyzing your data, that counts as research software development. You're doing research software development. So yeah, you're included in that. You'll understand different ways that you can trigger these workflows to happen and determine which triggers useful for different applications. Understand a couple of ways that you can like get data that is created by workflows, get data or objects or images, things that are created, get them out in some way. And if we have time, we'll see an example of using GitHub Actions for distributed computing. And overall, like the other important thing is that you'll get a bunch of examples that you can then use and build off of and play around with in the future. So giving you a place to start, like with GitHub Actions, that's really, I found useful in learning it, is like just starting with some example that's already there and tweaking it rather than sitting down and creating something from scratch. So, okay. A little bit of vocabulary. I'm not sure if everyone here is like a regular Git and GitHub user. I'm assuming not everyone is. And this workshop was built with those folks in mind. We're not going to be working with Git today, or really like GitHub that much in terms of like changing code or things like that. So a little bit of background, just some terms that I'm going to use unavoidably. A repository. A repository is just a folder that has your code and your data in it on your computer on github.com, where the changes to that folder are tracked by Git. Git is a version control software. Like I said, we're not going to get into that today. We have other videos from previous workshops that I'll send in a follow-up email if you're interested in learning more about Git. GitHub is a cloud platform. It's a website. It's a cloud platform for syncing Git repositories so that you have, a backup of your repository on the cloud so that you can share your code with your collaborators, with the public. But it also does other stuff, like it allows you to publish websites. It allows you to run automated workflows, for example, and a bunch of other stuff. So what is GitHub Actions? GitHub Actions allows you to run basically any workflow on a virtual machine in the cloud in a way that integrates with GitHub. So let me break that down a little bit. So basically any workflow, so this could be R code, could be Python code, could be shell scripts, whatever you want, on a virtual machine. So it's going to set up a like bare bones, it's like a brand new computer, right? A virtual computer that starts with like installing an operating system. You don't have to do that. It's doing that for you. But you can think of it like every time these run, it's like a brand new computer. And doing this in a way that integrates with GitHub. And so that means like you can trigger this to happen when certain GitHub things happen. So when somebody opens an issue, like makes a bug report, it could do something. When somebody changes the code in your repository, it could do something. And it allows you to easily incorporate workflows for common complex tasks that are created by others. So you don't have to know like the shell commands for installing R, for example. You don't have to know how to do that because somebody else has already figured that out for you and created an action that you can kind of plug in. So GitHub Actions is designed for a software practice called continuous integration and delivery, or CI/CD. And this is something that I think does actually translate well to scientific code and data if we think about it a little bit. So continuous integration is this idea of automating the integration of changes in your code or your data into the main version of your project. So think about like if your project was a website, right? If you're making a website and somebody updates the code for that website, you don't want it to just go live immediately, right? You want it to go through some checks to make sure it doesn't break the website, to make sure you have a chance to look at what the new version would look like. So in a research context, a couple examples that I can think of are like when your data is updated, you're out in the field, you're inputting, new data, and before that new data gets added to your repository, maybe run some data validation checks, check and see that those values fall within a reasonable range or whatever, right? That it's all there, right? That you didn't miss any plots or plants or whatever that you're out there measuring, so that you can get some feedback um, before you're away from the field site. Or maybe you have a collaborator that contributes some code and you want to, before you integrate their changes, you want to make sure their code adheres to a particular style, or you want to make sure it runs, right? So you can have that stuff be automated. Continuous delivery here is basically any way that you make your data, your code, the outputs of your code, reports, whatever, available for people to view or to download or to use. So in a scientific research data science context, maybe that's like every month we run a GitHub action that archives a new version of our data with Zenodo and gets a DOI. That's totally something we can do with GitHub Actions. Or every time your code or your data is updated on GitHub, re-render a report as a website that you can send to your collaborators so they can see new figures or updated figures with new data. So really, really useful stuff. And I encourage y'all to think very creatively about how you might use this in your own research. What we're going to do today, I'm going to go through a quick overview of like what a basic workflow for GitHub Actions looks like, how you define it. And then we're going to go through some examples. And I'm hoping that you all have lots of questions that you'll interrupt me and ask me. And we can just kind of see where it takes us. And then I have slides on here in this slide deck that are like resources that maybe we'll look at, maybe not. So how do we create these workflows, these GitHub Actions workflows? So they are defined with YAML. YAML is an acronym that stands for Yet Another Markup Language. You've probably seen YAML, maybe you haven't. But if you've ever made like an R Markdown document or a Cordo document, the bit in the header where you have the title and the author and the date and stuff, that's YAML. It's a super common way of like creating configuration files for lots of different things. So it's worth kind of getting used to. It is a little bit finicky. So YAML is comprised of these key value pairs. So here, for example, on is our key, and then it's got this workflow dispatch as a value. And indentation really matters. Indentation is how YAML knows like the nestedness of things. So without knowing what any of these things mean, I'll just show you like workflow dispatch is under on. Hello world is under jobs, and under hello world we have runs on and steps, right? So the indentation is indicating that. So to get GitHub Actions to work, and we'll see what they look like on GitHub, the website, in a second, we create these files that get put in a particular location in your repository, a folder called .github, and then inside of that, a folder called workflows. And you can put these files, you can call them whatever you want. So in this example, very, very simple. This is a real example, but super simple one that shows kind of all the pieces. So they all start with some kind of triggering event. In this example, it's workflow dispatch, which, as we'll see in a second, is just a button that you click on GitHub. Practically, like, not that useful actually if you want to automate things, but it's really great for examples. So all of our examples today are going to be on workflow dispatch, and I'll show you other options that are there. They all have jobs. So in this case, this workflow only has one job. We've called it hello world. That is kind of arbitrary, what you call your jobs. It's kind of weird, but yeah, so we have a job here. That job has a runner. So the runner is, what virtual computer is this going to run on? In this case, Ubuntu latest is the latest version of Ubuntu Linux. That's one of our options. But it could also be Mac OS. It could be Windows. It could be an old version. It could be the development version. So we want to check if our code is going to work on the new version of Mac OS or something like that. And then they have steps. And these steps are things that are run sequentially on this runner. So the first thing that's happening on this brand new virtual Linux machine is this. This is an action. This is one of those pre-built, pre-packaged things that I was talking about. So we know that it's an action because it has this uses key here, and action/checkout at v4. So this is the at v4 is version 4. We'll talk more about what this means, how we learn more about what actions checkout is. But this is an action that is super common because it just gets the files that are in your repository onto this virtual computer, onto this runner. So almost all GitHub Actions start with this. They all kind of look like this at the beginning. Here we've got another action. This one has a name. It's optional that we give it a name. And it uses an action, again, that installs R. So we don't have to know the Linux commands for installing R. We just include this action. And then the last thing here is a script. So this, instead of having a uses, it has a run here. And this is just a shell command. So you may not have seen this R script before. This is how, if you had a script called mycode.r, you have an R script, and you want to run all the code in it from the terminal, from the command line, you would type R script and then the path to your file. So that's what's happening here. So this could have whatever you want in it. It could be creating figures, it could be running a model, it could be tidying your data, it could be pulling data from the internet, whatever you want. So you can do a lot. Okay, I'll stop talking for a moment and see if there's any questions so far. If it's not fully clear yet, that's understandable. We haven't looked at one in action yet.
This is just a text file too, right?
Yeah, it's just text. I think probably the extension has to be .yml or .yaml for GitHub to recognize it. But yeah, it's just text.
Okay, cool.
Just plain text. Chris, question?
Yeah, Eric, hi. Thank you for all of this. The actions and rlib items under uses, those would not be in my own repo, right? Those are supplied by GitHub.
These are supplied by GitHub or somebody else. Really, anybody can publish one of these actions. And there's like a marketplace for them, which I'll show you later. And these these live in GitHub repositories that are not yours. So we could, and I'll show you later, we could go to, github.com/action/checkout, and you can see that's where this action is defined. And similarly, github.com/rlib/actions has a bunch of folders in it with things that group has defined.
I see. Okay, so these are like they're sort of like well-known paths, but they're also they're actually paths inside the GitHub architecture.
Yeah, they're it's like this is the sort of notation for how to do this, but it is also like something that you can find this on github.com, and you can find the code that is involved in this, and it's all set up for you, so you don't have to know how to do this stuff. And there's all documentation on all kinds of things you can do with these actions. So these are your building blocks, these actions that you can kind of piece together. And then you can also write your own stuff if you want to write R code or Python code or shell commands. You can do whatever you want. Yeah.
Gotcha. Thank you.
So let's all go to this template repository now, and we're going to create a copy of this template in our own GitHub usernames, organizations, whatever, so that you can play around with it. So I'll show you what I'm going to do here, and I'll give you all a moment to do it. If you navigate to this link, which I'll put again in the chat in case anybody joined recently, there's this green use this template button in the top. And when you click on that, you have the option create a new repository. So I'll click on that. And under owner, it asks me to choose an owner. I will choose myself. If you're a member of other organizations, they'll show up here, but you may not see all those things. And I got to give it a name. I'll call it GitHub Actions Workshop. And you can give it a description. I'm going to, for me, because this is just a demo and I have the template, I'm going to remind myself to delete later. But you can put whatever you want in there, or you can leave it blank. It's optional. There's one action in here that we're not going to get it to work today, but if you do want to play with it and get it to work, the repository does need to be public for that one to work because it publishes to GitHub Pages. So if you want to use GitHub Pages, which is GitHub's like website hosting service, the repository does need to be public. But I'll leave that up to you. And then we click the green button. So before I click it, I will give everyone a moment to do that. And if you could on Zoom, give me a green check mark or a thumbs up or something once you've got and clicked this green button, create repository.
Were we including all branches?
I don't think it matters. I don't
Yeah.
think I have multiple branches. Yeah. No harm in checking that box.
There's a branch for GitHub Pages in the repo, so
yeah, maybe click include all branches. We'll see. Maybe that'll make the thing work that I said wouldn't work. If you haven't checked that and you already did it, don't worry about it. Okay, does anybody need more time or running into issues? Okay, I think we're all good. Yeah. All right. I'm going to click the button then. Okay. So takes a moment to create this, and then I'll just give you a little tour here. So there's actually like a bunch of files in here. We're going to ignore most of them for now. And what we're going to focus on is we're going to go to this Actions tab. So at the very top, we see an Actions tab here. It's doing some stuff already, apparently. Don't worry about that. We'll talk about this, what this pages build deployment thing is later. But we're going to run an action. We're going to run our first one. So we're going to go to this hello world, 01 hello world. And we see this workflow has a workflow dispatch trigger. Cool. You can click this run workflow, run workflow. And nothing will show up right away, but if you refresh the page, you'll see something running. So this little orange dot indicates that it's going. And you can click on it and you can see this little orange spinny thing saying it's going. And then we can click on this here, this hello world thing, and we can watch it work. It's doing stuff. This is our virtual Linux machine. It's right now setting up R. So this is scrolling by too fast to read, but if I kind of pause it here a little bit, we see that it's installing a bunch of stuff that is necessary to install R, I guess. And yeah, so while that's running, we can take a look at the workflow file for it. So everybody, first of all, go ahead and run that. And actually mine has just finished. It was very quick. So once yours finishes running, the last thing here, we have this say hello bit, which you'll have a weirdly tall Yoda saying generated by our code this is. So if it all goes well, and you get a green check mark. So yeah, weird tall ASCII Yoda. So let's look at the workflow file, and then we're kind of flip back and forth here. So there's different ways to get to this workflow file, but I see it right here. I'll show you just another way. If you're on the like this kind of page here, there's also, oh, where is it? There's other ways to get to it. Hello world. Oh, here we go. If we were on this page, there's this hello_world.yaml. That's also the workflow file. Different ways to get to it. So let's look at it though. So we have our triggering event on workflow dispatch. We've given it a name. So this I didn't show before, but this name 01 hello world, that populates this right here. That's all it does. It just gives it a name on this actions tab. And under that, we've got one job, hello world, I called it, runs on Ubuntu latest. We have this action/checkout, which again, super common. Almost everything starts with that. It just gets the code and data that's in the repository onto this runner. This part is something that I've done I'll talk about what this is later. I have a slide about this. So this is removing a file. So it's just an example here of a shell command. So I'm running this rm.rprofile. This is, again, something that you'd run in like the terminal to remove a file. Most of the time, you won't do this. We've got an action that sets up R. This, again, this rlib/actions set up R, version 2. And then we've got some commands here. So a couple different ways to run R code. This first one for installing the cowsay package, since that's the only thing I need to run is just this install.packages cowsay. I've used rscript -e. -e is for expression, run an R expression. So normally the rscript command runs a whole R script, like you provide it with a path to an R script. In this case, it's just running this expression, install.packages cowsay. So we can run R code like that, or we can put it in a script. So what does this R script do? If I go back to the code tab here, we can find it. So it was in R, hello.r. Very simple, just prints out the version of R you have, loads the cowsay library, and uses the say function to get Yoda to say generated by R code this is. So that's what it does. So that's our very simple hello world example. I give you all a moment to click around and ask any questions you might have. Jeff, yeah, good question. So Jeff in the chat asked, let me get to the workflow file again, about this little character. This is not necessary in this case. I believe what this does is lets you have multiple lines, I think. This is a YAML thing, but I think I could have in this case just put it on the same line. And I think in the slides actually, yeah, in this example, we just had it right here. Yeah, I think that pipe lets you have multiple lines here, if I remember correctly. Yeah, Jim says that is the case in Ansible. So not sure what Ansible is, but yes, I believe that is. I think that's a YAML thing. So any other questions? So like I could have, I think, probably put another line here, R script r/hello.r. If I wanted to do it like all in one step, I probably could have done that. All right. So let's take a look at a couple more like practical, interesting examples then. So the way this works is in this template repository that you've used. It comes with these 6 examples, and I tried to come up with examples that I thought would be relevant, useful for the larger group. So a lot of these are data validation, because to me that seems like a really cool use for GitHub Actions. So imagine you're out in the field, you're collecting your data, you upload it to Box or something like that. You have your data on Google Drive or Box. And then you go over to your GitHub repository and you maybe click run workflow here on your iPad or your phone or whatever. And it'll run a workflow and run the validation script for you and tell you if your data is good. And that way you can know before you go back and run some code on your computer at your field station or your lab or whatever. That's kind of my idea for this. So go ahead and run this validate data. And while that's running, I'll kind of talk you through what it does. So let me look at the workflow file again here. So there's a bunch of text in here so you can read later what this does. Here's some examples of other event triggers that would be maybe useful for this. So on push means that whenever code is pushed to the GitHub repository, so whenever the code changes on this GitHub repository, it would trigger it to run. And you can filter that by saying, only do it when there's changes on the main branch, and only do it when there's changes to files in the data folder, for example. So that's what this would do. Comments, these hashtags are the character to indicate a comment. So it's same as R, which is really convenient. So you could like activate this by deleting it. You can have more than one trigger for the same action. So this could have workflow dispatch and push, for example. You can also do pull request. We're not going to have time today to talk about what a pull request is and how to do it, but basically it is a way on GitHub that you could request that changes be incorporated into some code. So your collaborator wants to contribute some changes, some data or something like that. And before it gets contributed, before it changes your actual code or data, it runs this and tells them, no, data are invalid, right? Something like that. So runs on Ubuntu latest. And then here we've got this renv stuff. So this is where in that first hello world, I was deleting this .r profile. So now is the point where I probably should talk about what renv is. So let me pause looking at that and go back to the slides here. So a note on renv. and why I'm using it. So renv is an R package. It is a super useful one. It's a good one to know about just in general, but also it works really nicely with GitHub Actions. So what does renv do? Basically, it analyzes your code in your project and figures out what packages it's using and creates this file that has information on what R packages your code uses, what versions of those packages are installed, and where they were installed from, whether it's CRAN or Bioconductor or GitHub or something like that. So this is really useful because there is a GitHub action that works with renv called setup renv here. And that will install all the packages, the exact versions, and from those particular places on the runner on GitHub using that renv.lock file. So there's other reasons you might want to use renv. Makes your code more reproducible, more portable. You can have like a different version of ggplot2 in this project compared to this project, for example. But it works really well with GitHub Actions. So we have this, and the other thing that it can do is can optionally, when it installs packages, installs all those packages, it can, instead of using install.packages function from R, it can use the pack package, pack. So pack is another really cool R package to just know about. The reason that it's super cool here is because on a Linux machine, which we're on, it will automatically detect any system dependencies and install those as well for you. So if you've ever used an R package that requires like a system dependency, like let's say you were trying to install Terra, which is for like geospatial stuff in R. Well, it requires that you have GDAL installed on your computer, which you have to do from the command line. This just does it, takes care of it for you. Yeah, question, please.
Okay, yeah. What does the workflow dispatch event do? Like, how do you use that? The workflow dispatch event.
The workflow dispatch event, that is what makes this button be here. So we can actually, wow, this is still running. We're gonna actually edit this action and we'll change it to be push, and then we'll see that this kind of goes away. So, yeah.
Thank you.
Let's see. So we were looking at validate YAML. Yeah, so env is this is a key that allows you to provide environment variables. I have an example later on where we talk more about what those are, but in this case, this is how in the renv package you like turn this behavior on. This is how you turn this setting on that it uses pack in the backend. So if I didn't have this, well, I'd have to have some separate steps that, installed GDAL on the Linux machine or something like that. And I'd have to figure out how to do that. But this will take care of it for me. So we have our actions checkout. We have our setup R that we've seen before. Here is an example where I'm using a particular R version. So I could set this to a number. I could say use version 4.4.0, or in this case, I'm saying use renv because the renv records the version of R that you're using when you create that lock file. So everything is like portable. And then we've got this setup renv action. So this restores all those packages, installs all the R packages that are recorded in renv.lock. And it also caches that. So caching is a thing you can do with GitHub Actions. We're not going to see any examples of like doing that manually, but this caches those packages so that the first time you run this, it's going to take longer than subsequent runs. Subsequent runs, it doesn't have to re-download and reinstall those packages. They are cached. They're kept in a cache somewhere. I don't know how that works, but yeah, they're in the cloud somewhere. And then we're finally running this validate.r script, which we can look at in a moment. Before we look at that script, though, are there any other questions about this file? Okay. Let's take a quick look at this validate script before we mess around with stuff. So I'm not going to go through this in detail. I'm just going to mention this uses the point blank package. I've done a workshop in the past on point blank, and I will, in a follow-up email, I'll send you guys a link to the video for that if you're interested in it. But it's a package for doing data validation. I like it a lot. It's like maybe a little overkill for for simple uses. But this file is validating some data. So we have some data included in this template. This is data that I worked on as part of my postdoc project. It's we can look at the data. It's in data Heliconia sample. So this is data from a reserve in Brazil in the Amazon, where this study was conducted over a decade or so. Every year, people would go out and measure the height, the number of shoots, and the number of inflorescences of these plants, Heliconia acuminata. So this is like an understory plant. And so we've got, the number of shoots it has, the height in centimeters, and the number of inflorescences. So usually they have like 2 to 5 shoots. And we're going to mess with that and get our validation script to trigger some things. But okay, so that's the data. Back to the validation script. Sorry, I'm jumping around a bit. So basically what this does, this is doing some data rearranging, and then we have the data validation here. So first it's looking to see that the number of shoots is between 1 and 20, that the height, and then it's going to look at the height between 0 and 200. Then it's going to look is the number of inflorescences between 0 and 6. That's basically all it's doing. We could create something much more complex, but for this example, those are the 3 checks. Okay. By now, I suspect your validation action is done, and we can inspect it. We see it's a green check, so that means it passed. It passed all those validations. It didn't error. But if what we have here is an R script that will error. It will return an error if it doesn't pass those validations. And that is actually really useful in this case. So what if we edit the data? So you can do this on GitHub. So if you find this data, find this Heliconia sample.csv. I don't recommend editing data directly on GitHub like this, but for this workshop, we're going to do it. So, okay, so this first row, we've got 2 shoots. We're going to change it to 200. And we've got 0 inflorescences. We're going to change it to -1. So if you click that edit button, unfortunately, it won't look as pretty. But I think you can figure out which numbers to mess with. So go ahead and change some of those numbers to be not within those bounds that the validation is looking for. So, and then once you've done that, you can click the green commit changes button. So I'll wait for folks to do that editing. Okay. So commit changes, I'll just leave this as it is, update Heliconia, and we'll just click the green button. Again, don't recommend editing your data like this, but so if you've been successful, you should see now like 200 shoots, -1 inflorescences. Go back to our actions. And we don't have this. We still only have this triggering on workflow dispatch. So it didn't rerun or anything. It didn't start now. But we'll go ahead and just run that workflow one more time with the button, the workflow dispatch button. This time should go faster because those R packages are cached. Yeah, Any questions while that's running? Okay. Well, I'm going to let that run for a little bit. The other thing we can do while that's running, so that we're expecting this to fail, right? Like it should give us an error. I'm going to go back to this workflow file. And I'm going to edit this so that next time we have a different triggering event. So I said don't edit files on GitHub is usually not a great idea, but GitHub Actions are actually an exception to this. Because it's GitHub, it's like aware that this is an action. And so we actually see this action marketplace. So this is, I did say I would talk about this, right? So we've got some options here of things to do. So set up Java JDK. So I don't know if your code was using Java, if you wanted to run some kind of Java application or something, well, you'd probably want to insert this action in there. You can search for things, right? So our setup Python. So if we needed to run some Python code, we would want to include this. And I've never clicked this button. Let's see what happens. Ah, there we go. It just gives us some examples here of how to include it, I think. Yeah, so uses, actions, set up Python, and then we have all these options for that you can provide, like a specific version, blah blah blah. So if we wanted to do this, we could just plop this in to our action, right? And we got to fix the indenting because the indenting is super important. But I'm not going to do that. We don't need Python for this. That's the marketplace. There's other ways to get to it. But what we're going to do here is change this to, instead of being workflow dispatch, we're going to change it to on push. So we're going to delete these comments here. Whoops. And I got to get my indenting right. So it's basically, I think it's using 2 spaces. So 1, 2, and those are on the same level, and our red squiggles go away. So now we have this running, instead of on workflow dispatch, it's running whenever there's changes to the main branch in the data folder. So next time we change the data, it will trigger it to run automatically. Okay, I'll give you all a moment to make those changes. So it should look like this here. Please let me know if at any point I'm going too fast or you want me to go back and show something. All right. So I'm going to commit those changes. And so now this is the new version of our workflow file. No longer has workflow dispatch. Now it is triggered on push to main in the data folder. Go back to actions. Aha, our validate data has now finished running. It errored. We got a red X. So this is our indication that something's wrong with our data here. Now, the way that I've done this validation, super, super simple. Just an R script that either errors or doesn't, right? So in this simple example, it has errored when it got to the shoots check. So shoots should have been between 1 and 20, not 200. And it errored and it's done. So we don't get to see the inflorescences error also. So we could go and we could fix them sort of one at a time, right? So, we can go back, and I'm going to do this just to demonstrate our new trigger, our event trigger. Oh, so the workflow dispatch button is gone. There's no workflow dispatch button anymore. And if we go back and we edit our data, fix the shoots to be not 200, but 2 again. and we commit changes. Now we have that running. So, and it tells us it's running on this particular commit that I made that was called update heliconia sample.csv. So this is still going to error because I didn't fix the inflorescences yet, right? That's one way to do data validation. There's some variations on that theme in this in the actions here, so we can look at those. We can run the validations as tests. So test that is an R package that is for running tests. Usually use it in the context of like you're making an R package and you're testing it, but you can use it for testing your data. So this is an example that uses that. And the benefit of using this method versus just an R script that either errors or doesn't is that you get to see all the errors with this one. So we can go ahead and run it. Run validation tests here. So we can have multiples of these running at the same time. So this is still going. Let's check on this one. Installing R packages still. Yes, Chris, I can slow down a little bit. Sorry, I'm jumping around a lot.
Yeah, no,
Thank you for
that's
letting me
fine.
know.
Thank you. I got out of sync here.
Yeah. So right now I'm looking at the simple, the second example, the validate data that has been running now after I fixed the data, or I fixed one wrong number in the data set.
Right.
And it still errors, right? Because we still have now a problem with the number of inflorescences. So we get an error here. So
Okay.
exceedance of failed test units where value in full, which is inflorescences, should be between 0 and 6, right? Because we made it -1. So this is the simple, like, it's an R script that either errors or doesn't, validates your data. You can write that code however you want. Okay. The third example here, this run validation tests, this is the one that uses the test that package. And while this is running, I can look at the workflow file, and I can kind of tell you what this does. So this is going on workflow dispatch again, but probably more useful would be on push or something like that. And all this stuff is the same. So we set up, we check out the repository, we set up R, we set up the R packages, and then we run this test.r file. And we see that this has failed now. So let's look at test.r.
Sorry,
So,
we're on 3 now.
Yeah, this is number 3. Yeah,
Okay.
the validation tests, I think I called it. So test.r, this is all that it has in it. Library test _dir tests. So this is, I'm not going to go into detail about how test that works. Happy to help you with that some other time. But we have in our test folder these tests. So we're testing that the data makes sense, and in that we have our same kind of expectations that shoots are between 1 and 20, height is between 0 and 200, inflorescence is between 0 and 6. But it's set up a little bit differently as tests rather than just a script that errors or not. So why is that useful? Again, if we look at our results here, we would see not only the one error. Well, now there is only one error. So, but we will see a whole like test output here. So we see how many tests failed, how many had warnings, and how many were okay. So, and this is like going through time. So at the end here, we have one failure, 2 successes. So it actually goes through all 3 tests and gives us a report. So 2 of them passed, 1 of them gave us this error. So another example for you to look at and study and build on for data validation. Now, that was not so different than the first example, other than it's using test that, but it's still basically, the workflow is very similar. It's running an R script. In this case, it's one that runs these tests a little bit differently. Okay.
Okay, and we should be running 3 manually.
Right now, it is set only to run manually. You are welcome to play around with editing that to run on push or something like that, and then you could change the data, and we could see it. We could see it run and give us multiple errors.
Okay. Yeah, I'm still trying to catch up. Yeah.
Yeah, no worries. Yeah.
Okay.
Any other questions from folks? I know it takes a while for these actions to run, so.
Well, what's sort of frustrating is it takes a moment, 4, 5, 10 seconds to start. So it looks like nothing's happening.
It looks like nothing's happening, especially with this like workflow dispatch. Sometimes if you just refresh the page, you'll see it. It just doesn't refresh immediately or doesn't show something popping up immediately. Yeah, you click that button and it's like, wait, did it go?
Right.
Yeah.
I assume that's a function of GitHub itself being a giant global platform rather than something, sitting in my own office.
Yeah, I think so too.
Yeah, okay.
Yeah, that happened to me. I was running the validate data and then I was running it again because I got a little behind and it didn't show. And then I canceled one of them. And at first it didn't show it was canceled. Then I was like, oh shoot, should I cancel? Did it work? Like what's going on? I had to refresh the page. Yeah. It's definitely not like showing in real time what's going on. So a little bit of a limitation, I guess.
I think I am caught up now. Thank you.
Sure. Yeah, no worries. So this is, maybe a little bit more useful. Here we've got a couple of examples where we're actually rendering something that then you could share with people, right? So here we're switching to an example where maybe we want to create some kind of report for our collaborators that includes figures, includes tables, includes statistics, whatever. And we want that to be always up to date as we update our data and our code. So that's what this render README and publish validation report are kind of both about. So the README in a GitHub repository, if you're not familiar, is a special file. If you have a file called readme.md, it is this. So this here is generated by that readme.md file. And in it, I have an example at the very bottom. So most of it is an explanation of what the template repository is. But at the very bottom here, we have this example like report. And all it's doing is drawing some histograms of our data set. So what we're going to do with that one is we're going to find that workflow file. So here it is, render_readme.yaml. And we're gonna add that this will trigger on push to branch to the main branch. So if I edit this file, and maybe I should have just had this on to begin with. Oops. Okay, I think that's right. I see a red squiggle here. Bad indentation. I wonder if I have to do that. Okay. So we have to have on workflow dispatch : with nothing after it. And then on the same indentation level, we have push branches main. So this will now trigger with the button or and with a change to the repository. Oh yeah, in the chat. Thank you again, Christina. That's a great reminder. When GitHub Actions fail by default, you get an email. So that's another thing that's really nice is you can have something run on a schedule also, or when other people are making changes, to your repository, and you'll get an email notification that something's gone wrong. So that's really useful. So after this workshop, you'll check your email and you'll have a bunch of weird emails from GitHub. Sorry. You can safely ignore those. All right, I'm gonna make this change so that this workshop or this workflow now works when we make changes to the data. And okay, so we've got that now that works on workflow dispatch or on push. And we're, ooh, it's loading slowly for some reason. Uh-oh. Temporary. Okay, good. We're back. So it'd be bad timing for GitHub to go down. All right, so we're gonna look at our README here. These are our what you call it? Our histograms. So this goes, all the way up to 200 because we had some errors in the data. Perhaps that's why, I can't remember. Inflorescences. So what we're going to do is we're going to edit the data, and it's actually running right now, but we can go ahead and find that data again to trigger that to run so that we can see a difference. So I'm going to make this super wrong again, and I'm going to change it to like 500 shoots. So our x-axis on that histogram should go all the way to 500 now if I do that. Okay. We edited the data, and now our action should be triggered and should be running. So if I go back to the Actions tab, boy, GitHub's moving slow today. All right. So we see that it's running this update render readme.yaml. That is actually the one from updating the YAML file, but there should be one from updating the data too. Maybe I need to refresh. Oh, GitHub doesn't like us running all these actions at the same time. No, people use GitHub Actions. There are, thousands of these running at the same time. So I'm wondering, yeah, I actually don't know why it's moving so slowly. Their status page says everything's good. Well, I can show you the YAML file on my computer while we wait for that to load. Let me find it here. So it's in this hidden.github folder workflows, and that was this render readme. So this is just a text file. You could open it up in like any old text editor. For me, I guess it opens up in BBEdit, but it could be like just the notepad or whatever, and you can view these, or you can open it up in RStudio as well. Can I make this bigger? Oops, view text display, zoom in. Really, no keyboard shortcut for that. Okay, so same kind of stuff we've seen before. Triggering event. We've got jobs called build deploy. It runs on Ubuntu latest again. We have pack turned on. Permissions here is allowing, this is a special key that is allowing the GitHub Actions runner to have permission, in this case, to write to your repository, because it is going to be replacing that readme.md file with a new version that has the new figures in it.
How did you figure out you needed to do that?
That is an interesting question. I think how I figured that out is so the way this action is working is the README is written as a Quarto document. So Quarto is another thing that we've done workshops about before. This is a sort of a successor to R Markdown. It is a scientific publishing tool, authoring tool. And one of the things you can do with it is publish to GitHub in a very variety of different ways. And I'm wondering if this is where I learned that. I don't remember how I figured that out now. They have some
It looked like
examples. Yeah, so it's one of
in
the
these examples.
examples here where they have this permission contents right. So I think that's how I learned this. Chris, yeah. Oh, disruption with GitHub services. They are investigating.
Oh no, we
What
broke
timing?
GitHub.
Yeah, the half a dozen or so of us right in this room. No, I doubt
Oh
it that
yeah,
we had anything to
just
do with it.
bad
Just
timing
very
there.
bad timing. Cool. That's great. Well, we can talk about things still. We can walk through what these all do. Oh, there it's maybe back.
Oh, Chris
All right.
has a question too, but
Yeah, an
YAML
error in
formatting.
the YAML might be indentation. So if you think it might be with the indentation, okay, things aren't working. What did the error say?
It says there's an error on the line. It doesn't say what the error is.
Yeah.
Oh,
So
I'm sorry, you've got a colon after workflow dispatch there.
yeah, I put a colon after that,
Okay.
I'm not. I guess that's a YAML thing. I don't know. I've never seen
Yeah,
where there's a colon and then nothing after it, but I think it wanted that. So when I
I
had
believe it. Okay.
when I click this edit file, this is another benefit of doing the editing of these YAML files on GitHub, is it does give you like a little red squiggle somewhere if you don't have that colon, which is kind of indicating
Okay.
to me that something was
And
wrong.
yeah, YAML's really it's a terrible format for humans.
I've heard that. Yes. I've heard there's a lot of controversy around it. So
Like
this
when it
action,
works, it's great, but
yeah.
Well,
Yeah,
and
I've heard.
for something like this too, I don't know how quickly you saw an error with the YAML, but with GitHub Actions, if you're trying to get something to work, you have to like keep rerunning it, and it's going to keep putting off these jobs, and like I don't know, be kind of
yeah.
onerous feeling for sure.
So this has errored, and it has errored in a step that really it shouldn't have. So I think this has to do with GitHub having issues right now, but it does give me an opportunity to show y'all that you can rerun jobs. So even if you don't have that workflow dispatch button, you can kind of manually rerun something, especially if you think like it wasn't actually, there's not actually a problem in my data. It just failed at installing R or something like that. And there are these sort of occasional like, something didn't work one time and then you rerun it and then it works. That does happen occasionally with GitHub, not very often. But this is one of those where it's like commit changes. That shouldn't be a problem. So I'm just going to say rerun failed jobs. Maybe it'll work, maybe it won't, but we can still kind of move forward and talk about what this is doing, because this introduces one of several ways that we can actually get stuff that happens on these runners out of the runners into the real world and like use it. So what this does is it installs R, does all the setup stuff, installs the R packages. And then we have this render step. And so our README is written, the one that we edit is this .qmd. This is a Quarto file, like I mentioned earlier. And Cordo's pretty easy to learn, especially for something basic like this. We can look at that file in a bit if you'd like. And it's rendering it to, so with Cordo, you can render your Cordo documents to all kinds of formats: PDF, Word, HTML. You can make presentations, PowerPoint, all kinds of stuff with Cordo. One of the things you can render it to, one of the formats, is something called GitHub flavored Markdown. So this is what GitHub can read and turn into a nice looking, like, basically website. And that's what that README is. It's just Markdown, which is another kind of markup language thing. Markdown is a great thing to learn. So our Markdown is Markdown, right? It uses Markdown for formatting. So it's rendering it to GitHub flavored Markdown. And we're doing that with an action. So that's already supplied to us by Cordo. So the cordo.org site has all kinds of information on publishing, and this is where I found out about this action here. So this renders it to GitHub flavored Markdown, but then it's, it doesn't go anywhere. It's rendered, it's on this virtual computer, this Ubuntu latest runner. How do we get it materialized in the real world for us? We have to tell that virtual computer to commit those changes to our repository. Just like we've been committing changes when we've edited the data or those workflow files, and they then become permanent, visible on that repository, this virtual computer is committing the changes. And again, I did this by searching for a GitHub action that can do this. And so this will commit all the changes in my repository using this commit message render readme. And it is still failing.
Will that not set up an infinite loop? Because if we've got this script set to run on commit, and the last thing the script does is commit.
That's an interesting question. It apparently does not.
I mean,
so I had not thought about that, but I assume whoever Stefan Zweifel is thought about that and somehow avoided it. or maybe it's something that GitHub has thought about and doesn't allow that to happen. Yeah,
hopefully
it does
GitHub
not in practice
smarter
create
than
an
that.
infinite loop.
Okay.
So, well, this render readme is still failing for reasons that it shouldn't. So I'm going to assume that this is something to do with GitHub being down right now. So, but I can show you, yeah, anyway. So I was going to show you how I found this. So this is a good moment to talk about the GitHub Marketplace. I'm just going to Google GitHub Marketplace here. And yeah, thanks, Jeff. Yeah, just bad timing for GitHub. So GitHub Marketplace has got a bunch of stuff in it. We're interested right now in actions. So if I click over here and click all actions, I can browse through them. But I can also, well, here's one right here. There's checkout. We're familiar with that. We've seen that a bunch of times. It tells us on these pages how to use it. So there's other options here that we could include, which I'm not. And we could search for commit in here, maybe. I actually find, here's a commit check action. That's not what we want. I actually find it easier to just search for like GitHub action commit changes, something like that. So just adding GitHub action to the beginning of a Google search, and then maybe looking for a link to the marketplace. And here we go. Here is an action. This is a different one than the one I used that somebody else has created. Endbug has created this one, add and commit. But looks like it does kind of a similar thing. So we maybe could have used this one instead. So this is the marketplace. And again, yeah, this has, frequently asked questions. It has examples. It has all the possible inputs that you could include in this, all kinds of stuff. So there's lots to read on all these marketplace pages. And that's one place that you can find things. Another one is if you see examples in here. Again, I kind of mentioned this at the beginning, but the way that these work on GitHub is URLs are like to a repository are the username or the organization / repository name. So rlib, if I copy that and I go to github.com/rlib/actions, I can find a GitHub repository that has all these actions in it. So set up R, set up pandoc, set up R dependencies, all these things. I can click on those, and then they each have their own README that tells me what the inputs are and how to use it and gives me examples. So that's a really nice way. So let me actually, what I'm going to do, since GitHub seems to just not be working right now, is I'm going to open up RStudio and show these actions to you in RStudio. Sorry if this is disorienting a little bit, but it's not there. Let's go to, here we go, GitHub Actions for research. The other actions that I have in here. So here's this README, this Quarto file. So format GitHub flavored markdown. And so it has R code in it to generate those plots. And then in the actual finished README, it just links to images right here that are generated. So, and then that gets committed along with these images by that action. So we have a README that then can update based on our data. So, and we can have this run whenever data changes, or we can have it run on a schedule. The next one that I was going to show is this validation report. So this is similar. It's again like publishing something to the web, but here we're actually using this Quarto publish action. And this is going to publish it not as GitHub flavored markdown, but like an actual website that is hosted by GitHub Pages. And this is really cool. So I use this a lot when working with collaborators because I can create a report for them, which I can show you like what this very simple example one looks like. You in web browser. So this is what it looks like. This is again using that point blank validation, but we've got this like nifty data validation report here that is like, it's totally HTML. It's interactive. I can click this button and to like download a CSV file of all the data that has failed this validation, which is pretty cool. We've got, links, we can have images, we can have all kinds of stuff, all the Quarto stuff. And this I'm showing you locally on my computer. But if GitHub were working, we could get this action potentially to publish this to GitHub Pages. And so that is a really cool option. And not that hard to set up. So this one, you do have to run Quarto publish command manually the first time, because that does some things, sets some things up on GitHub for you, creates this GitHub Pages or GH Pages branch and does some other stuff. But then after that, this will run, in this case, you would maybe want to have that run every time there were changes to the code. So you would use on push as your trigger potentially. So that's another way to sort of get things materialized in the world, right? Is to publish it to GitHub Pages if it's a report, for example.
Eric, if I can
Please.
interrupt, just sort
Please
of
do.
I don't know, maybe a more meta question. So there's like, you've got 6 actions in here, and we've edited 2 of them to add the on push to main.
Yeah.
And what I've obviously discovered is that when I went back and edited the data, now I've got 2 actions running. Is that a desirable state where you might have multiple actions running at once, or would you
It
want to?
might be.
Okay.
Yeah, it depends on what you want to do. So you might have a repository where anytime you change your data, it both renders a report and you know, moves your data to a box folder or something like that, right? Like
Yeah.
you might want to have multiple things happen. So yeah, you can set those up as separate actions. You can you could also set them up as just separate jobs within the same action. So we haven't seen an example
Yeah.
yet of multiple jobs, but every job runs on a separate runner. So you could have one action that has a job that deploys the published report, and also one that renders it as a PDF and sends it to you by email or something like that, right? You could figure out a way to do that. And those could live in the same action and just run as two separate jobs.
Yeah. Okay. Thank you.
Yeah. Yeah, you can, so we saw some examples of like filters here. So, some of these actions only run when there's changes to a particular folder or file. So that might be desirable to sort of control. So you don't have, you don't need your data validation report to rerun when you change your README, right? When you change some text in your README because your data didn't change. So, but I have a slide about the limitations of GitHub, and they're pretty, you have a lot of ability to run these runners. You're not gonna run out of the ability to run these for free, or unlikely to, unless you're really doing kind of heavy duty stuff. So let's see. This matrix one is the last one. So let's not look at that yet. And I will go back to my slides here.
Yep, GitHub does seem to be working a little more normally now, at least for
Oh,
me.
okay.
Just by the way.
That's great. Well, let's look through the slides, and then maybe we'll get one of these actions to work and be able to see it. So we talked a little bit about the events. We've seen push, pull request, workflow dispatch. There's also schedule. Schedule is the other sort of commonly used one, I think. So this one, like for example, have worked with some folks that have some sensors that are collecting data, and then every I guess month it's pulling the data down, wrangling the data, and archiving that data set with Zenodo to get a new version DOI. So you can say, run it on the first Monday of every month, or run it every hour, or run it at 2 o'clock on the 22nd day of every month, or something like that, right? You can be very specific about how you want that schedule to run. And all of the events are here in this link that you can use.
For the scheduling one, is that like, do you have to set that up like a cron job, like with
You have to use cron, yeah. So let's see, schedule. I can show you what it looks like a little bit. So cron syntax is like so, minute, hour, day of month, day of week. So you can do things like run at the minute 2 and minute 10 of the 4th and 5th hour of every day, or run at at minute 15 of every hour of every day. You can do lots of stuff. And there's like a cron, this cron tab guru is where this is where I go to figure out how to set these up and translate them to English. So this is, at 4:05 on every Monday. So you can mess around with this. And then these are how you supply that schedule. So you go on schedule, cron, and then in quotation marks, your cron specification. Runners. So we've mentioned these. We've only seen examples of Ubuntu latest. this is a nice default again, because if you're using that package and rn, it like installs system dependencies for you. But maybe you have some R packages that are only for Windows or only for Mac. You can use Windows or Mac runners. Or a common thing to do for like if you're creating an R package is you have a setup where it's testing your code on all of these operating systems with different versions of R, so that you make sure it works for everybody. So if that's important for you for your code, you can use these use different runners. The full list of runners is again at this link. There's like an Ubuntu dev, Windows dev, Mac OS dev, or you can specify particular versions. And they're not huge computers, right? They've got 4 CPUs, 16 gigabytes of RAM, and 14 gigabytes of storage. So, but they're not tiny either. So there's not a lot of storage here. Storage is the big limitation. Yeah, and so this is like artifacts that are created or things that are created by your workflow, or not. You don't want them to exceed 14 gigabytes, or it'll complain, I think. And yeah, you can use all these for free. And if you have a, I can't remember the terminology for it, but you can upgrade your account on GitHub from the basic one to, I can't remember what it's called, enterprise or something, for free if you're an educator or have a .edu email address, basically, work for a university. So, and then you get slightly like higher, you get higher limits on these runners. I think you can have something like 150 runners running simultaneously. So there's no like real practical limit there unless you're really doing heavy duty stuff with GitHub Actions. So yeah. Jobs are, slides are formatted a little weird. So these jobs we've talked about, and we've seen mostly examples so far that only have one job, but you can have multiple jobs. So here's an example where an event triggers 2 jobs, one of them running on Ubuntu latest, one of them running on Mac OS latest. And they've got steps are within those jobs, each happening on their own separate runner. So, this is an example where we've got both of them start with checkout. This one does some R stuff. This one does some Python stuff. You could totally do this. We've talked about actions a bunch. So I showed y'all the marketplace for these. These are some really common ones, the ones that I've showed you so far. Checkout, setup R, setup Python, setup RN. And yeah, again, searching in the marketplace or just searching, Google for whatever you want to do, and then adding GitHub Action in there is a good way to find those and find examples that other people have used. Thank you. GitHub Education account. Yes, thanks, Jeff, in the chat. It's got a link for GitHub Education where you can apply for that, I guess, upgrade to your account. So Jim Davis asks, grabbing random code from the marketplace is secure, right? I believe the actions that are actually in the GitHub marketplace, I believe they are vetted in some way. I am not sure. Don't quote me on that. And I believe, GitHub has some safety rails in place. Like we saw the permissions, right? So if we want an action to be able to write to our code and like overwrite files, we do have to like opt into that. So that's a good thing. Variables. Yeah, I want to talk about variables.
I want to say about this, secure code too. I mean, it's always a good idea to like look into who's creating, anything that you use that's online. I mean, if it's like coming from somebody or some organization that like is pretty reputable, like it's probably likely safe. If it's some random person that's not been used by anyone else, and maybe you like question it a little more.
So these, yes, exactly. So that reminds me, these actions that start with actions, these are GitHub. GitHub has created these. The ones that are somebody else are somebody else. So in this case, rlib is the like R consortium or the R core organization, I think, they have created this action. So that's a reputable source. But then we saw an example of that one for committing changes that was from some person. And so that is sort of up to you to vet that. And, you know, in this case, it's an action that's super widely used. So I feel like I trust it because of that, I guess. Maybe I shouldn't. I don't know. You can set variables in a variety of different ways. These are useful, and we're going to see, I think, in this last example, how they can be really powerful. So environment variables, this is not a GitHub Actions specific thing. These are things that just exist on computers. You can set environment variables for your runners on GitHub Actions with this env key. And you can just give it a variable name. By convention, I don't know if it's required, but by convention, environment variables are all caps with words separated by underscores. And you can give that any sort of value you want. And then this is super useful because in your R code, you can access environment variables in R with the sys.getEnv function. And so this we'll see in our sort of last example is a way to pass information from your sort of workflow file into your R script and do some really cool stuff. Chris says this all caps is just by convention, but they use one that has a lowercase I just to be cute. I like that. The other kind of variables that you can use. So environment variables are, again, this is not a GitHub specific thing. These GitHub secrets are a specific thing though. And secrets can be stored in GitHub and accessed in workflows like so. So we have key, colon, we have whatever key it is, right? And then we have this $, curly brace, secrets dot, whatever you called the variable. So secrets are useful when, for example, you have a password or an API key that your workflow needs to access, maybe in an R script. But you don't want that to be published publicly and be viewable in your workflow file. So you can, on GitHub, you can like go to your settings and it's under secrets and variables, actions. You can create a new repository secret. You can call it whatever you want. And this is how you access that. So secrets.secret var, whatever you want, whatever you called it, right? My API key, whatever. And then the last little bit of cool thing that you can do, and this relates to our last example, is a matrix strategy, something called a matrix strategy. Usually where you see this in sort of the conventional use of GitHub Actions is we want to run these tests for our code on macOS, Windows, Ubuntu using R, like the release version of R, the next version of R, and an old version of R, something like that. All the possible combinations, permutations of that. But we can use this in other kind of more arbitrary ways. So here's a very contrived example where we have under our job, we're saying use a strategy matrix. Letters, this is I can call this whatever I want, are A, B, and C. So then what happens is it actually is going to launch 3 runners, one for each of these letters. And on each of those, it's going to set up R. And then it's going to run this R script where it prints a environment variable called alphabet, and that I'm defining right here, and it's pulling it from this matrix. So what we're going to get in this is 3 runners, three jobs, and the first job is going to print the letter A, second job is going to print the letter B, third job is going to print the letter C. So and we see this kind of syntax again, this $ curly brace. Matrix refers to this, and dot is like the next level, and letters refers to this. So this variable then, it's like iterating over it, like a, in R, it would be like lapply or something kind of. So I'll show you all that last example, and maybe we'll try to make it work on GitHub. I see a green check mark, so things are maybe working. And then we can go back and run some of these other ones. So the action I have here, model as metadata, very, again, a little bit of a contrived example, but this would be, imagine you have some code that you want to parallelize, right? You want to run the same code, same script, but for multiple, in this case, it's going to be weather stations, but it could be multiple states or whatever you want. So what we're doing here is we're using this matrix strategy to give a bunch of station IDs. So ASMET is the Arizona Meteorological Network. And there are a bunch of weather stations throughout Arizona that collect data, and we can access it with an R package called ASMET-R, which is one of the packages that's recorded in our rn-vloc file. So that gets installed for us from GitHub, I think. And in the code, in the R code for this, which refers to this, this asmet.r script, it's going to use an environment variable to like plug that in. So we can look at that script real quick. And actually, since I have RStudio open, I'll just show it to you on there. Maybe slightly less disorienting. So we have a sys.getEnv here, asmet station to give us the station ID. And then in the asmet.r package, we have an azdaily function. So we're getting the station ID, whatever that is, right? Whatever that environment variable is getting plugged in there. So we have this running. Now it's going to launch a separate runner for every station. And it's going to create all these reports, or it's going to get all these data sets as an output. So what is it doing? It's saving this summary as an output. I can run this actually, see what it looks like. So it's creating this very simple CSV. So it's got, here, we'll just do it without the, right. Looks like this, right? So it's got our station ID, it's got an R squared for a model, it's got a bunch of model statistics for this one station. So what this is doing is then it's going to run that job for every station because we're using this matrix strategy and passing that into an environment variable. And it's going to save it using the station ID again. So we're reusing that station ID as the file name. Now, how do we get this? This is another way that you can access stuff that's created by GitHub Actions, this concept of an artifact. So GitHub Actions can create artifacts. Artifacts, they don't stick around forever. They are sort of temporary. You can download them though. And the very cool thing about these is these can be used by other jobs. So we have then a second job that downloads the artifacts from the previous job. So it's going to download all of these artifacts that were generated and combine them using a different R script. So a little bit of a contrived example because we don't really need to do this on a separate runner for every station. This is not like a heavy duty script, but imagine it is. Imagine it's a heavy duty script. So let's run it and see what it looks like, and then we can inspect and ask questions. Let's hope it works. So feel free to run that on yours as well. I'm going to refresh the page and see if it's going. Looks like it is. So here we see all of these jobs are launching. So this is a little bit different. We have here, this first step is our matrix thing, our matrix jobs. I'm seeing errors. So maybe things are not quite working right. Still, let's inspect, see what happened. Okay, so it failed at the setup R step. I know that that's not my fault. So some things are still a little bit funky, apparently. But we get the idea a little bit here. It has launched all of these jobs. And this one errored in a different way, I guess. Yeah. GitHub Actions encountered an internal error. Yeah, unfortunately, stuff's just not working still. But what would happen is once these all succeeded, then only then this combine step would happen. And that is because that is because in our YAML file, we have said needs. So this job called combine needs this job that was called asmet to have finished, to have completed. So we can chain these jobs together and do really complicated, interesting stuff with this. I'll say that this is where the workshop that the materials that I linked to in the very beginning, they have a better example of that. It's just an example that I can't explain the science of very well. So, but they have pairs of images that are being used to calculate glacier flow, I think. And this is all running on they're running like every possible combination of pairs of images in separate runners and then combining them all together into some model and creating like an animated GIF of glacier flow. And it's very cool. So I encourage you to check that out. We've also used that in our own work with the forest inventory analysis data sets where we're doing stuff by every state separately and then combining them all into one big data set. So the matrix there is states. And yeah.
When might
Yeah,
you
go ahead.
want to just, and I don't know if you have ideas about this, but because when would you want to use these like matrix things on GitHub Actions as opposed to something like the HPC?
Yeah, so that's a great question. You can run like parallel jobs like this on HPC by creating these Slurm requests. I would say GitHub Actions, the pros there is that you can more easily schedule things. I think you can schedule jobs to happen on the HPC, but I think it's a little bit easier here. So if you want something to happen every Monday, or if you want to also, it's easier to trigger it to happen when you change your code. So the triggering events are like a built-in thing of GitHub Actions where they're not on the HPC. However, you're more limited in terms of your storage and like computational power on GitHub Actions. So if you're doing something that really does require like a lot of RAM or a lot of disk space, GitHub Actions, you're going to run into limitations because you have 16 gigabytes of RAM. If you're on the HPC, you could run a job with 50, 100 gigabytes of RAM, whatever you want. You can request as many cores as you want. So yeah, it's not for super, super heavy duty kind of computational stuff, but it's nice for automating things. Well, that was my last example. So I have some slides here that kind of list a little bit of like pros and cons of these examples, but I think we've talked about these mostly. There's plenty of time for questions and for ideas. So I'd love to hear like, hey, I want to do this. Is that possible with GitHub Actions? If you have any ideas about that, I'd love to hear those. I also want to point you to resources, and I will send these links out again in a follow-up email, but we have the full documentation for GitHub Actions, which is a lot. But there is a quick start here, and there is there's a lot. There's a lot of stuff here. So there's plenty to read about here. If you're looking for something specific, it's also searchable. And what else? We've got this Actions Marketplace, which I talked about. And then also, again, I want to point you to this GitHub Actions for scientific workflows from this tutorial that I was at, this longer format one. And then, of course, we are always available. We have drop-in hours every Wednesday from 2 to 3 virtually that you're welcome to join. We also offer for folks in the ALVSKI acronym, which includes CALES, a data science incubator program where you can propose a project and work with us. And that is pre-funded, aka free for you. And you can also join our mailing list to get updates about future workshops and other opportunities to collaborate. So yeah, thank you all for coming. I'm gonna stick around. I'm assuming there's maybe some more questions or some ideas about how you might use GitHub, but that is the like end of the slides and the demos because GitHub wasn't working. So you're also welcome to take off if you'd like to. Thanks for coming.
Well, this was really great. Thank you, Eric, and the data science group. I've been to a couple of these, and I'm really glad they exist. I really appreciate this.
Awesome. Thank you. Yeah, thanks for coming. Thanks for the good questions too.
Well, so one of the things, so I'm over at the Lunar and Planetary Lab and on campus, and we actually have a self-hosted GitLab instance, and
Yeah.
I've made use of the GitLab's own CI/CD
Yeah, they have
technology.
an analogous thing. Yeah.
Yeah, I'm just wondering how, if you've had any experience kind of translating between the two, or any sense of like
How they compare.
how they compare. Yeah, I mean, we're using GitLab because it's self-hosted, so we can
Yeah.
put it behind our firewall.
Yep.
Um,
No,
but
I haven't actually, I haven't messed around with GitLab, whatever their version of Actions is called. I can't remember what it's called even.
I don't either.
So I don't know, but I do know that it exists, and I have this like vague sense that it's like fairly capable and comparable, but I don't really know.
Yeah, okay. Okay.
Yeah, that's an interesting idea. Yeah, there's other tools out there for doing this kind of stuff, and GitHub Actions is like, and the GitLab version are relatively new,
Yeah.
but really powerful. So yeah, GitHub Actions unfortunately are limited to GitHub. So if you have
Yeah, sure.
another
And
thing like GitLab or Bitbucket, then you gotta, yeah. But I think,
certainly GitLab doesn't have access to the GitHub Action Marketplace, and
yeah,
I bet I bet
but
our
I suspect there's an
self-hosted,
equivalent.
yeah,
Um,
but I bet our self-hosted one doesn't have easy access to the main GitLab Action Marketplace equivalent.
You might,
interesting.
I mean,
Yeah, maybe.
you might also be able to look at things on GitHub Marketplace and then implement them in GitLab if it doesn't already exist,
Yeah, for sure. Because they're,
potentially.
if what they are basically shell commands in a YAML format.
Yeah.
Yeah, using
Yep.
using Docker whatever containers, which I think is, I don't know, is that I assume that's what.
I think that's an option. I don't think they're actually technically Docker containers. You can though.
Oh, interesting.
You can, there is a YAML argument or something to run it as a Docker container. But I'm not exactly sure about the details of how that virtual machine is actually existing. I don't know.
Yeah,
But yeah,
I
you can
build
probably do something very similar in GitLab is my guess.
yeah,
I
okay,
mean,
Yeah.
it looks like they use, yeah, they do have a similar setup on GitLab where they use a YAML file, and it looks like it's different, like syntax for the different like keys.
yeah,
But yeah, like I was trying to say, like the sort of actions that you can do in GitHub Actions, you could maybe create your own version of those actions in GitLab if they're set
They
up
don't already
similar.
exist. Yeah.
If they don't already exist, yeah.
yeah, that seems likely. Okay,
That could
cool.
be, I don't know how challenging. It could be very challenging or it could be very easy.
Yeah. Hopefully,
Yeah,
Chris,
and
this was at least helpful in terms of giving you ideas about how you could use this sort of thing, and hopefully, it's not too hard to translate over to GitLab.
yeah, I think I currently use it in our self-hosted GitLab to build Java doc whenever I make a
Mhm.
commit into the main branch,
Perfect. Yeah.
which is very cool. And I think what we'd like to do is do uh, automatic testing on
Mm.
you know in, uh,
Hmm.
in similar conditions. Yeah.
Yeah. Yeah. Absolutely. That is a ideal use for that sort of thing. Yeah.
But this was great. Thank you. I really appreciate this.
Yeah. You're
And
welcome.
like I said, the whole data science groups efforts here. I'm very pleased to have learned about them and wish that I'd known about it maybe 10 years ago.
Thanks. I don't think we existed 10 years ago, but yeah.
Oh, then I
Thank you.
I don't feel so bad then.
Oh, our group's only been around in teaching for maybe 5 years. So yeah,
Okay.
you're not too late on the
Okay.
update.
Glad you found out about it. Yeah, absolutely. So
Also, if there's like workshop like topics that you think would be useful, feel free to suggest to us.
yeah,
We're happy to
Yeah,
teach
sure.
what people are looking for. So
Sure, we'll do. We'll do.
absolutely. Any other questions, inspirations? Anybody have an idea of how they want to use GitHub Actions? Okay. Well, I'm going to call it then. I'll let y'all go and have a great rest of your day. And yeah, look forward to an email. I'll send you some links for follow-up and more learning and a survey for you to take to tell us what you think about this. So
Cool.
thanks again for coming. And yeah, hope to see you around.
Great. Thank you.
Bye.
Toodaloo.